Hello, and welcome to our lesson on calculating the area of various two-dimensional shapes. In this lesson, we'll build on your existing knowledge and learn how to calculate the area of 4 different types of shapes: squares, rectangles, parallelograms, and trapeziums. We'll start by reviewing the basic formula for calculating the area of a square. Next, we'll move on to rectangles and learn how the area formula for squares can be extended to them. We'll then explore the area of parallelograms and understand how it slightly differs from the rectangle. Finally, we'll tackle the area of trapeziums and derive the formula used to calculate it. In our previous lessons, we've built a solid foundation by discussing the area of a triangle. Understanding the fundamental formula for calculating the area of a triangle has provided a good starting point for tackling other shapes. Using this foundational knowledge, we can now explore the formulae for finding the areas of squares, rectangles, parallelograms, and trapeziums. This is essential for solving a variety of real-world and theoretical problems in geometry. For example, imagine you are an interior designer needing to calculate the floor space of different rooms in a new building. Knowing how to find the area of these shapes will enable you to provide accurate measurements and make informed decisions about materials, layout, and design. By the end of this lesson, you'll be equipped with the skills to tackle such problems with confidence and precision. Let's get started. Let's dive right into the main body of our lesson. We'll start with the simplest shapes, squares and rectangles. The area of a square is given by the formula area equals side 1 times side 2. However, since all sides of a square are equal, side 1 equals side 2. Therefore, you just need to multiply one side by itself. Area equals side 1 times side 1. This can be written as side squared. We'll now move on to rectangles. The area of a rectangle is found using the following formula: area equals side 1 times side 2. We can rewrite this in a more general formula as area equals length times width. We can write this as area equals L times W. Next, we will move on to parallelograms. A parallelogram may look complicated due to its slanted sides, but calculating its area is quite straightforward. The formula for the area is area equals base times perpendicular height. Here's a step-by-step way to understand this. Firstly, identify the base B of the parallelogram, which is the bottom side. Secondly, determine the perpendicular height, h. The perpendicular height is the perpendicular distance from the base to the opposite side, not the length of the slanted sides. We can find it by imagining a line coming straight down from the top of the parallelogram at a 90-degree angle to the base. And that's everything there is to it. Area equals B times h, or base times perpendicular height. Notice that the sides for rectangles and squares are perpendicular to the base, and so even though these equations all look different, they could all be described with the formula area equals base times perpendicular height. Finally, the trapezium is slightly more complex. The formula for the area of a trapezium is area equals half a plus b times h. Here, a and b refer to the lengths of the parallel sides, or, as we learnt in the previous lesson, bases. H is the height, the perpendicular distance between the parallel sides. Let's break down why this formula makes sense. If you take the average of the two parallel sides by doing a plus b divided by 2, you get the average length of the two bases. Multiplying this average length by the height gives you the area of a parallelogram that represents the average area covered by the shape. To visualize this, you can imagine breaking the trapezium into a rectangle and 2 triangles. By doing so, you can see that the area calculation borrows from the principles used for rectangles and triangles. In today's lesson, we explored the methods for calculating the area of 4 fundamental two-dimensional shapes: squares, rectangles, parallelograms, and trapeziums. We began with the simplest shapes, squares and rectangles, using the straightforward formulae of side times side for squares and length times width for rectangles. We then moved on to parallelograms, where we learned that the area is calculated using base times height, emphasizing the importance of the perpendicular height rather than the slanted sides. Finally, we tackled the trapezium, understanding that its area is found with the formula 1/2 times a plus b times h, where a and b are the lengths of the parallel sides and h is the height. By mastering these techniques, you will be equipped to accurately calculate the area of these shapes, a crucial skill in both real-world applications and theoretical geometry problems.